All right, here we go. Next couple. So we've got x to the negative zero point 0.5 times 2 times the quantity 2 times x to the 0 0.5 minus x to the negative 0 0.5 all over x to the negative 1 power. Now, I would recommend that rather than distributing this first, I would get rid of our x to the negative 1. Let's bring it on up. So I'm going to essentially multiply the top and the bottom by x and x. Those will cancel out, give us 1, and really, in fact, it just brings that x value, that x to the negative 1 up here as a times x, and that will be multiplied by the negative. So that's x to the first times x to the negative 0.5, giving us, so our next line, we'll have x to the positive 0.5. This is negative 0.5 plus 1 is positive 0.5 times 2x to the 0.5 minus x to the negative 0.5. And now we don't have to worry about our denominator anymore, and we can go ahead and just distribute. So x to the 0.5 times 2 times x to the 0.5 is 2x to the first power. And x to the 0.5 power to the minus x to the negative 0.5, that gives us x to the 0 power. And anything to the 0 power is just 1. So this is 2x minus 1. All right, next we have, let's rewrite this first off in fractional exponential form. And so we've got 2a, that quantity, to the 4/3 power divided by 2a, and make sure you're writing those parentheses. It's the entire quantity of 2a. It's not just a. If we didn't have the parentheses, it would say just the a is to the 4/3 power, and here to the 1/6 power. Now that we need to get common denominators, and so 6 and thirds, we just need to multiply this top one by 2 over 2. And that's going to change everything to 2a, quantity 2a to the 8/6 over 2a quantity to the 1/6. That'll give us, I'll go this way, that'll give us 2a quantity, the quantity 2a to the 7/6, which gives us, if we were to switch this back to a radical, that gives us, and actually you don't need to switch it back to the radical even. Notice that there's this is more than 1, meaning we could take one of these out right now and get 2a, and if I subtracted 1 from this, we'd be left with 2a to the 1/6 power. All right. Now, if you're going to write that as a radical, we'll kind of go back from this step right here, and we're to write that as a radical, we would end up with the 6th root. That was from the 6th there, the 6th root of 2 to the 7th and a to the 7th. And for the exact same reason, we have 7 2's in here. We need just 6 of them to pull it all the way out. And so let me kind of write this over here. That's 2, and with a 2 left inside the radicals, the 6th root, not the 7th root, 6th root. And then if there's 7 a's multiplied together, we need 6 of them to get out. So 2a now, and then 1a left over, which these two right here, sorry, a lot of lines going around, say the exact same thing. The exponential form, radical form. Those two say the exact same thing. All right, and last one, kind of run out of room again, but I think we'll we'll get some room to put it right over here. So we have 2 to the n to the 1/3. Now notice just the n is to the 1/3 this time, not the 2. With the parentheses, now it's saying the entire quantity, but that's not what's going on here. This is just to the n. And really, if you think about the order of operations, that makes sense because exponents happen before multiplication. So 2 to the n, or sorry, 2 times n to the 1/3, and that times the quantity n to the 2/3 plus n to the 1/3. And negative 1/3. Negative 1/3. Kind of tough to tell, but there is a negative right there. So as we distribute this out, 1/3 n to the 1/3 times n to the 2/3, add your exponents, and we get 2 to the, make sure that we're explicit about this being a subproblem, 2 to the n to 3/3, which is just 2 to the n. Over here, 2 times n to the 1/3 times n to the negative 1/3. Well, 1/3 times or plus negative 1/3 is really just plus 2 n to the 0, and n to the 0 is 1. So this is 1 times 2, so plus 2. 2n plus 2 is your answer there. All right, I know these are going to be a little complicated at first, but try to just go through step by step. And again, I know you guys are going to find success with it. All right, hope that helped.